So we are going to start by changing our code so that we're calling a stored procedure instead of an ad hoc query. So we're going to set the data adapter's select command type to stored procedure. And then we're going to add an input parameter. We're going to use the add with value method, and we're going to add a parameter called search with the value from the search text box. Then we're going to add a check to make sure there is a value in the search text box before we add the parameter. Now we'll only add the parameter to the stored procedure if there's actually a value in the search text box. Now we just need to change our call to the GetCustomers method in the page load to call the proper stored procedure. In this case, the stored procedure name will be USP underscore customers underscore get names. In the search command button, our call to the GetCustomers method will include the stored procedure USP underscore customers underscore search. If we take a look at the stored procedures in the customer orders database, you'll see that we are simply running the same code in the stored procedure that we were running in the ad hoc query. So first let's take a look at customers underscore get names. You can see here that all the get names stored procedure is doing is selecting the first name column and the last name column from the customers table. If we take a look at the search stored procedure, we can see that the search stored procedure is doing basically the same thing, selecting the first name and the last name from the customers table with a where clause that says where first name equals the search parameter or last name equals the search parameter. So basically the same code that we had in our ad hoc query in the page, but this time we're using an input parameter for the stored procedure called search. Now I don't want you to think that the reason that the SQL injection attack isn't working is because our parameter is only 50 characters long, so we're going to change that to 500 characters. Not necessary for our search parameter, but just to illustrate the point that we didn't defeat the SQL injection attack because it's too long to fit in our parameter. So I've given it plenty of length for our SQL injection attack to fit in our input parameter. So let's execute that. And before we run our code, to ensure that our search is only performed when the search button is actually pressed, we're going to check for Postback on page load. So if we go to the page load event, before we call the GetCustomers method, we're going to check to make sure it's not a page postback. So if not is postback, then we'll run the GetCustomers USP customer underscore get names. Otherwise, we won't run that, and we'll run the GetCustomers from the command button's click event. Now if we run our code, we should get the same results as before, but with more efficient code and less code duplication. And we should be protected against SQL injection attacks. So let's run that code. Page load works as before, but now when we search for user by first name, search for Antoine, we get Antoine Victor. We search for Brown, we get Snoopy Brown. Let's see what happens if we try our SQL injection attack again. now our SQL injection attack doesn't work and no results are returned. So it's not that difficult to protect against most cross-site scripting attacks. We did it in this demo with the simple call to a store procedure. Please click the subscribe button to be notified when the next video is published.